if we're looking at how pH affects solubility, we learned in chapter 16 that sodium chloride, that's a salt, and since sodium chloride is formed from the reaction of a strong acid and a strong base, then do you remember that that's a neutral salt? How we did that is we said, oh, sodium's a group 1. Well, those ions have no effect on pH. And chloride comes from a strong acid, so that has no effect on pH. Therefore, that's a neutral salt. You with me? You're having to remember what we did at the end of chapter 16. pH, if the salt is neutral, pH has no effect. Has no effect. Is it effect? I hate effect. Here. pH would have no effect if it's a neutral salt. If the salt is basic, can y'all give me an example of a salt that would be basic? In order to be a basic salt, y'all, it's got to come from a strong base and a weak acid. Oh, well, potassium hydroxide is a base, but that would work. Okay, KOH is a basic salt, yes. Give me another one. How about lithium fluoride?
That's what I was thinking.
Okay. Those are examples of basic salts. What does that mean, y'all? That means if you dissolve them in water, that they would have a basic pH. It would be a little bit above 7. So, if the salt is basic, if you increase the pH and you make it even more basic, then it will become less soluble. If you decrease the pH, or in other words, make it acidic, it would become more soluble. Why? It's Le Chatelier's principle. So that's your rule for basic salt. That's your rule for neutral salt. If the salt's not neutral and it's not basic, then it's an acidic salt. For example, like ammonium chloride, because the ammonium is the conjugate acid of ammonia, which is a weak base. If the salt is acidic, then what would increasing the pH do? Make it more soluble. And decreasing the pH would then make it less soluble.